दिव्या, कनिष्का, एकता, शर्मिला, श्रुतिका, ऐश्वर्या, good afternoon everyone. No beta, that still okay, we'll start the class. Send the link, inform everyone to join as fast as possible. Okay, fine. Now look here. Last class morning itself we were discussing about cathode ray experiment. I discussed about J.J. Thomson experiment. In that I told we have taken a discharge tube. Discharge tube is exactly made with glass, and we have discussed about 20 centimeter, means 25 centimeter approximate length of the discharge tube was there. There we have taken 2 electrodes. Okay, now you can see one cathode and one anode has been taken. Now that after that we have also seen that a voltage, the current of exactly 10,000 volt has been applied, and a vacuum pump is there through which the pressure kept on getting reduced. The pressure kept on getting reduced. Everyone, good afternoon. The pressure kept on getting reduced. Fine. So now we are going to see that last class in morning I discussed about something. I want to get that information. I told you that morning whatever I have taught, I am going to ask in evening. The cathode ray experiment, first we know that matter was indivisible. It will not be further broken down. Okay, so after that we understood that yes, matter consists of subatomic particles. The matter consists of atom, and atoms are exactly having subatomic particles. Now can you name the subatomic particles? Quickly name the subatomic particles. You have to name the subatomic particles. Quickly name the subatomic particles. Subatomic particles. What and all are the subatomic particles? Yes, neutron, proton, electron. Kanishka, absolutely correct. So morning we discussed about subatomic particles. The subatomic particles were neutron, proton and electron. Correct only, Ekta. The subatomic particles were neutron, proton and electron. Absolutely correct. Neutron, proton and electrons were the subatomic particles. After that we understood one experiment we have exactly seen. In that we were talking about the property of charges. So exactly we have seen an electrostatic, like I discussed about a pen and rubbing the pen on head and checking, and what you called taking it near the bits of the paper. The bits of the paper will get clinged by the pen or the what you called the ruler, which is we have what you call the plastic ruler, which we have rubbed with an woolen piece of cloth, or we have used a pen, plastic pen, pen, or we have used a glass rod and we have rubbed the glass rod. John Dalton, yes beta, we have exactly rubbed with a silk cloth, and then we kept it near the piece of what you call papers. We saw that it is getting cling on that. So that content we have discussed. So what was the basis of that experiment? What was the basis of that experiment? What was the basis of that experiment? What I have discussed in morning. What was the basis of this experiment? So this experiment we have discussed in morning, in that we have seen some observation. What was the basis of that observation? Come on everyone, start answering the questions. What was the basis of the experiment we have done in morning? Basis of the experiment we have done in morning. What was the basis of that experiment we have done in morning? Quickly say. Type and say. Where is Vishal? Where is Keshav? Yes, charges. Absolutely correct. Correct. Hi Ashwin. So we have understood one very important point there, and that important point was that the matter is made up of atom, and the atom have charges. This was the basis, means this was the basic point we have seen, that is proton positive, neutron neutral, electron. So that activity proves that electrically charged particles are present in atom. Absolute Shruti, that was the basic point I was exactly searching for. So the basic point what we were searching for, that yes, atoms are made exactly, the matter is made up of particles, the particles are exactly atom, and the atoms are exactly what you call have charges. So that was the basis of that experiment we have exactly used. Now after that we talked about J.J. Thomson discharge tube experiment. In that discharge tube experiment, morning I was discussing another important point. In that we talked about discharge tube. What was the length of the discharge tube taken? Come on, quickly tell me. The length of the discharge tube taken was, come on, start answering the question. The length of the discharge tube taken was, what was the length of the discharge tube taken? Length of the discharge tube taken. The discharge tube taken for this experiment, that length was 25 centimeter. Absolutely correct. Now after that we have exactly seen another thing. Two plates were taken, electrodes were taken. What was the current supplied there? What was the amount of current supplied there? In that experiment, what was the amount of current supplied there? Come on, quickly start answering the question. Amount of current supplied. Amount of current supplied. What was the amount of current supplied? Aishwarya, absolutely correct. The amount of current supplied was 10,000 volts. Absolutely correct. At normal pressure, was there anything in the discharge tube? Was there any activity in the discharge tube? At normal pressure, was there any activity shown in the discharge tube? Come on, quickly answer my question. Yes, absolutely correct. All of you are back to back correct. 10,000 volt was the amount of current that is passing. Now I'm asking another question from you. No change. Absolutely correct, Rahul. There was no change in that. Yes, light was going fully. No. There was no change seen in the discharge tube. There was no change seen in the discharge tube. That was the thing we have seen there. But when we reduce the pressure to 0.1 mm, when we reduce the pressure to 0.1 mm with the help of the vacuum pump, what we have seen? What we have seen when we reduce the pressure, what we have seen, what happened to this? What happened to this discharge tube? What happened to this discharge tube when we have exactly seen that we have exactly reduced the pressure to 0.1 mm? Full light glowing. Absolutely correct, correct Vishal. The light started, means the full discharge tube started getting illuminated. It started exactly showing light. No specific direction of light, but it was exactly showing light. Fine, absolutely correct. So light was glowing in the discharge tube. Light was glowing in the discharge tube. This was the thing we have exactly seen. Now next important point. When we reduce the pressure to 0.01 mm, means 0.01 mm of mercury, when we reduce this, then what specific thing we have seen there? Then what specific thing we have seen? Means when we have reduced the pressure, means when J.J. Thomson was doing this experiment, when he reduced the pressure to 0.001 mm of Hg, so that time what what thing he has discovered there? Come on, quickly tell the answer. What thing he has discovered? Yes, exactly, one part of the discharge tube started glowing. Sorry today for 20 minutes late, because I was exactly searching the correct note for you. And you know what? It was glowing in the anode side. Absolutely correct, Ekta. It was not glowing in the cathode side. It was glowing in the anode side, which exactly gave us a concept that something is coming from the cathode side, something is coming from the cathode ray. Some rays are coming from the cathode rays and it is going towards anode. Some rays are coming from the cathode ray and it is going towards anode. This was the thing we have exactly seen. So rays are coming from cathode going towards anode, and these rays were called as cathode rays. These rays were called as what? Cathode rays. What was the name we have given to these rays? These rays were exactly called as cathode rays. Cathode rays. What was the name of these rays? These rays were the cathode rays. So now next, what we are exactly going to do here, we are going to understand the production of cathode rays and the properties of cathode ray. Okay, so now at the time of so now on applying high voltage between the electrode and result observed, no flow of current at ordinary pressure, glowing entirely tube at 1 mm, but exactly dark band was formed when we have reduced the pressure. But when the exactly production of cathode rays was done at 0.001 mm pressure, okay, and the side of the anode was started glowing with one specific color, and that color was greenish yellow, that is greenish yellow light of fluorescence is exactly there. Greenish yellow light called fluorescence was exactly at the side of anode. Was exactly which side? Was exactly at the side of anode. This was the finding when we have reduced the pressure of the discharge tube to 0.001 mm of atmospheric pressure. Okay, so now this was the finding. Now we are going to understand the properties of cathode rays. Okay, so now the next work what we are going to do is we are going to understand the properties of cathode rays. Properties of cathode rays. Fine. So now our next work is to understand the properties of cathode rays. So we came to know that some rays started exactly coming out. Some rays are exactly coming out from cathode and it is going towards anode, and the rays name we have given is cathode rays. So there should be some properties of these rays. Okay. So now our next work is to know the properties of these rays. The first property we are going to talk about is cathode ray travel in straight line. Somebody will say that my name is something else, then am I going to believe that? Until and unless I will not get a concrete proof that my name is something else, I am not going to believe. Okay, so the thing here is when somebody will be telling you that cathode rays travel in a straight line, then what could be the concrete proof that cathode rays are traveling in straight line? They may be moving here and there. How to say that specifically these rays are moving in straight line? How to say specifically these rays are moving in straight line? Then this shows by the fact that if an object such as a metal cross is placed in the path of the cathode ray, they cast a sharp shadow of the object at the back. See, what is exactly the single concept here I am just going to use is, if I am standing, my shadow will be casting at the back. So why my shadow will be casted? My shadow will be casting because we have taken one property of light, and the property of light is light travels in straight line. Light travels in straight line. In class 10th you will be understanding the dual property of light, that is light is traveling in straight line and they are exactly forming waves. So that is the different thing. But right now we know that shadow casting is that property of light when we discuss that light is traveling in straight line. Shadow casting is that property of light when we say that the light is exactly traveling where? The light is traveling in. Shadow casting is that property which discuss what? Shadow casting is that property which discuss what property of light? Which discuss what property of light? Come on everyone. Shadow casting is the property which discuss what property of light? Which discuss what property of light? Yes, that the light travels in straight line. Absolutely correct, Darshini. That is, the light is traveling in straight line. The light is traveling in straight line. So here also, when we have seen that, we are exactly taking a very important point that when something will be exactly present as like, if my hand is there and light is falling in my hand, just back of my hand shadow will be casted. In the same way, what we have done in this discharge tube, in the same discharge tube, we kept a metal plate. In between this place we kept a metal plate. So when we kept a metal plate, see the way we have kept the metal plate here, we saw that the shadow of this metal plate is casted in this region. The shadow of this metal plate is casted in this region, and this is exactly proving a very important point that light, cathode rays are traveling in straight line. What it has proved, that cathode rays are traveling in straight line. So first property of cathode ray that we have seen is that cathode rays can travel in straight line. Cathode rays are those rays which can travel in straight line. What did I said? Cathode rays are those rays which can travel where? In straight line. Cathode rays are those rays which can travel in straight line. Why? Because it is casting shadow. Why? Because it is casting shadow. If an object or a metal plate is kept in the place where the cathode ray is traveling, then it will cast the shadow of that metal plate in the opposite direction. So this is exactly an important finding or proof that cathode rays travel in straight line. Cathode rays travel where? Cathode rays are traveling in straight line. Come on, understood this point? Say quickly, did you understood this point that cathode rays are exactly traveling in straight line? This is one of a very important property. This is one of a very important property of cathode rays. They travel in straight line. They travel where? They travel in straight line. Fine. So now the next important point we are going to talk about is cathode rays are made up of material particles. So now the next important property is cathode rays are made of material particles. Now material particle means what? See, we understand one very important thing, that particles are exactly existing. Particles are existing and they show their presence. Okay, they show their presence. So if I'm saying that our wind air is exactly air is containing dust particles, so I just used a word particles. Dust particles are there, and how we are exactly experiencing the particles or something which is present in air when wind will be blowing. At that time we experience the presence of air which is exactly having particles. Fine. So that is an important finding there. Now cathode rays are made up of particles. Correct, Darshini. That is, cathode rays are exactly made up of particles. But how to prove this one, that cathode rays are exactly made of particle? I told you about air now, कि when moving air is called wind. That is the simplest definition of wind, air. So moving air is exactly called as wind. Now the presence of wind is felt when it is striking our body. Yes or no? So it can also rotate the blades of the windmill. Yes or no? So if with they are exactly having particles, and these particles when strike the blades, they have the capability to rotate the blades. In the same way, cathode rays are exactly having, they are made up of particles. How to prove this point? Now what we have done here is, we kept one rotating wheel here, mounted axle. We have exactly light mica paddle, a very light, no heavy metal content. We have not taken any heavy metal pedal. We have taken a very light mica pedal. So mica pedal means pedal which can rotate, like cycle is there now, when you are pedaling the wheel is rotating now. In the same way, very lightweight plates we have taken, mica plates we have taken, and that exactly with that plates one pedal has been formed. So this pedal is connected, and when the cathode rays were traveling, the pedal started moving. The pedal started moving means these particles are capable of moving the pedals. So these particles which is coming out, the rays which is coming out, they have particles, and these particles have the capability to move the pedals. to move the pedals. So we have understood another important point here, that the cathode rays, first we learned that cathode rays moves in a straight line. Another important point what we have learned here is that cathode rays have material particles. They are exactly made up of material particles, and these material particles are capable of moving the pedals. They are capable of moving the pedals. This is a very important finding, okay, because I am not teaching you from book point of view that you only have to write the CBSE examination and your concept is over. No, please kindly, I am not teaching for that first. So I am teaching you for your future, for your concept. So just understand cathode ray, two important properties you have understood. First property, cathode rays moves in straight line. Second important property, cathode ray are made up of material particles. Cathode rays are made up of what? Cathode rays are made up of material particle. Now next we have exactly seen that cathode rays carries negative charge. So it can rotate the mica plates now. So that means it is proving one thing, that they are made up of material particle. So this shows by the fact that if a light pedal wheel made up of mica is placed in path of cathode rays, such as and it strikes the blade, it can rotate the blade. So this is an important finding. Now we are going to go to the next point, which is exactly cathode rays carry negative charge. Cathode rays carries negative charge, and this is a super important point. This is a super important point, that cathode rays are exactly negatively charged rays. They contain material particle. That's the important point. Third important point, key points. What are the three key points? Cathode rays travel in straight line. Second important point, cathode rays are containing material particles. Third is cathode rays are negatively charged. Third is cathode rays are negatively charged. So this shows by the fact that when an electric field is applied on the cathode ray, they deflect towards positive plate. So let's see what happened there. How we came to know that cathode rays are negatively charged. So there should be some proof. Now I told you, nothing can be done without proof. Means if I will say you something, why you are going to trust me first? You should not trust me. As a student, we should not trust to anything until and unless there is a proof of that. Then only we can be able to understand that yes, the proof is there, and now with the help of this proof we can exactly understand the point. Now here the most important thing is when high voltage current is applied, but only one thing what they have done is they kept an extra plate. So an extra electric field has been applied. You know that electric field will have one positive terminal and negative terminal. So when we have kept an electric field in this discharge tube, then what we are finding that the cathode rays used to the cathode ray used to travel straight. So it's supposed to go straight, okay, if it is not carrying any charge. If it is not carrying any charge, then it should have moved straight. If it is not carrying any charge, then it should have moved straight. But rather than moving straight, see here, the current is exactly passing. So current positive terminal and negative terminal is there. So the rays are little deflected towards positive. So that means it is having attraction towards positive, and it is repelling the negative. So that means these rays are negatively charged. See, negative, same charges are repelling each other, and unlike charges are attracting each other. Same charge repel, unlike charge attract. Very good, Darshini. Super. This is exactly showing that Darshini is very nicely attentively listening my points. So whether you proved or not, no, Darshini, the most important thing here is, beta, I want you all to have the best knowledge. My focus only goes for, like if I am teaching, I want you to give the best, so that, and so only I took, first I thought that I will teach only whatever is there. Then I thought that why should my children be less than others? They should be knowing this thing, so that in future when somebody will ask them, they will be the first one who is going to answer all these questions. Okay, so I'm a bit selfish for all of you. So only I just gathered all these informations, and I just added this into the PDF. So only I took extra minutes, beta. But you have to understand all these points. So cathode ray, beta, so electricity is exactly, we are seeing that, see, this electric field is there. So electric field will have a positive terminal and a negative terminal. So these cathode rays, rather than going towards negative side, it went slightly deflected towards the positive side. And it is exactly proving a very important point, point that cathode rays are negatively charged. Cathode rays are negatively charged. Okay, so this proof is exactly telling that what are the important points we have seen till now about cathode rays? Come on, quickly say, what are the important points we have seen till now about cathode rays? Come on, come on, come on, quickly do it. What are the important points we have seen about cathode rays till now? Come on, quickly type and send. Let's see. Okay, why there is an anode with hole? Beta, look here, this anode will allow the cathode to travel in a straight line. It is exactly doing what na, Shruti? It is exactly, the cathode is negatively charged. So now extra anode is trapped. Anode is trapping the negative charges. Fine. Anode is trapping the negative charge. It is exactly sinking the remaining electrons. So why there is a, because beta it is, see, actually what is happening here, Shruti, that all the rays are going straight na beta. Now this anode is trapping all. Okay, now from this hole only little bit will be going. So since little bit will be going, then understanding the behavior becomes easy. Okay, so if all will go na, Shruti, so if all will go, then we cannot be able to see the deflection. Then it will exactly make a full band of color. It will make a full band of color here. Okay, Shruti, it will make a full band of color. Then this plate keeping now will not work. So we kept a whole anode so that extra rays will be trapped. Only few amount of rays can move so that we can be able to see the deflection clearly. Okay, we can be able to see the deflection clearly. Now you understood, Shruti? We can be able to see the deflection clearly. Super, very good. So Kanishka, oh, Sharmila is having net problem. Oh. Okay, understood na, Shruti? So beta extra rays has to be trapped so that we can be able to see specifically is there any deflection in the rays or not, because it will illuminate this region. So now we are seeing a deflection in illumination. If full might have been taken, then full might have illuminated, but only this much is there, so it is very easy to see the deflection. It is very easy to see the deflection. I hope you might have understood this point. I hope you might have understood this point. Come on, quickly tell me. Yes, Shruti understood. Super. Sharmila is having, tell Sharmila to watch this video later. This is a very, very important point. Okay. Now we are going to go towards all the properties we have exactly traced out. Now the next property what they are telling is they produce green fluorescent on the glass wall of the discharge tube as well as on certain substance such as zinc sulfide. That is not so important property. The most important properties are cathode rays are those that can travel in straight line. They are made up of particles, very good, and they are negatively charged. The three important points what you have written, Ekta, Darshini, Krisha, that is absolutely correct beta. That is, they are negatively charged, they are traveling in straight line, and they contains material particles. They contains what beta? They contains material particle. Now the next important point about cathode rays are they can also be capable of producing heating effect, and they produce X-rays when they strike against the surface of hard metal. So this is a very important point. Cathode rays can produce X-ray when they strike against the surface of hard metal like tungsten and molybdenum. So this is again important point. I'm just discussed fluorescent, so already we have seen that that yellowish green fluorescent color it has exactly made, that we have seen. So that point I think it will be there in your brain, but this remaining 2 points, 5th and 6th point, I think you should remember that cathode rays can produce heating effect. They can produce which effect? Cathode rays can produce heating effect. Cathode rays can produce what beta? Cathode rays can produce heating effect. Cathode rays are going to produce what? Cathode rays are going to produce heating effect. That is one of an important point. Next important point, we are exactly going to see that cathode rays can produce X-rays. So X-rays which is exactly coming, it is what type of rays? They are cathode rays, and they have the power or the capacity to penetrate the metal surface. Okay, they have the capacity to penetrate which one? They have the capacity to penetrate the metal surface or hard metallic surface like tungsten and molybdenum. Tungsten and molybdenum. So now a very important question comes into our mind that atom is made up of charges. Now one charge we talked about is cathode. one charge we talked about is cathode, and cathode is negatively charged. Cathode is negative. Now we are exactly going to think about, can we relate cathode with electrons? Can we relate cathode with electrons? Can we do like that? I want my children to participate into this conversation with me and give the answer. So I discussed one very important point to you. I said a very important point to you, that cathode rays are negatively charged. Okay, and after that I am asking one question to you, that since we know that atoms are exactly having charges, so can we say that one of the charge of atom is negative charge, and that negative charge is called as electron? So am I correct, or you think any fault is there in this statement? Am I correct, or you are finding some fault in this statement? Come on, I want my children to just think about it and say clearly. Think about it and say clearly. Is it okay? Vishal, your work is over now? Are you really here, Vishal? Shared with V flat? So we have seen exactly about electrons. Now we are going to understand about electron from the study of the various properties. That means above, the two most important results observed as follows, that cathode rays are made up of material particles and cathode rays carries negative charge. So cathode rays are, there is no fault in the statement. Okay. So now next important point here is cathode rays are made up of material particles. This is one of the property. Another property is cathode rays are carrying negative charge. So these two properties we have seen. The negatively charged material particle constituting the cathode rays are called as electrons. So this is what work I was just asking about. I asked one question, Vishal, and you are talking about V flat. I am exactly asking one question, that I told one statement. Is that statement okay for you or not? We understood one thing, that matter is exactly made up of atoms, and atoms have charges. By our morning experiment, we came to know that atoms are having charges. Okay. Now after that, we in this today's experiment we are seeing a very important point, and that important point in today's experiment we are seeing that cathode rays are there na. So these cathode rays are negatively charged and they are containing material property also. Okay. That is what, Vishal, I was expecting a correct answer from you, so only I got angry. So now we have to understand one thing, the negatively charged material particle constituting the cathode rays are called as electrons. Constituting the cathode rays are exactly called as electrons. Constituting the cathode rays are called as what? Electrons. So cathode rays, another name, what we are saying, the negatively charged material particles constituting the cathode rays, means some cathode rays are made up of material particles, and these material particles are exactly what? They are electrons. Understood or not? So cathode rays are having material particles, and these material particles are what? Electrons. So that means we learned a very important point, that these rays are all electrons moving. So what is moving here? Electrons moving. So these rays are exactly having what? What is exactly example 4. So what is exactly moving here? What is exactly moving here? It is exactly electrons which are moving. What is moving here? Electrons. So now we are going to understand about electrons. Okay. So now electrons, the negatively charged material particle constituting the cathode rays are called as electrons. Now I hope till here everybody might have understood. Everybody might have understood whatever till now I taught you. Did you understood? Did you understood whatever I discussed till now? Did you understood? Understood this point, beta? About electrons I have discussed. The cathode rays are exactly containing the material particles, and these material particles are, hi Manpreet, how are you? Okay, so these material particles are nothing but electron. So we have understood one simple logic. That logic was exactly missing in the previous chapter, where we were discussing about atoms, and we understood that atoms were indivisible, which cannot be further broken down. Okay, but now we have understood that no, one experiment we have done, and that is electrostatic, where we have exactly discussed that all the materials, they have charges on this body, means charges on its surface. So this property told us something, that atoms have charges, and now we have seen one of the charge of atom. Good evening Manpreet, where were you? Yeah, I was not well, in between I got COVID, so only I took a break of 4-5 days. So negatively charged particles will be there. Okay, so these negatively charged particles are exactly nothing but the electrons. So we have discussed about J.J. Thomson. What is electron, please? Yes, I am going to discuss about it, but I am just going to explain about this point. That is, when J.J. Thomson has done that experiment, in that cathode rays were coming out. So these cathode rays were negatively charged particles, beta, negatively charged particles, and they were traveling in straight line. So now we came to know that these negatively charged particles are nothing but electrons. So the cathode rays are constituting a negatively charged particles in it. So the rays which were traveling from cathode to anode, they are negatively charged particles. And what name we have given to the negative charged particles? The negatively charged particles name is exactly electron. What is exactly the name of the negatively charged particle? The negatively charged particle name is electron. Now you have understood, Darshini? Darshan, now you have understood, beta, the negatively charged particles is nothing but electrons. Yes, Darshu. So they are exactly electrons. Now we have to understand charge and mass of electrons. So definitely one thing we have seen in J.J. Thomson experiment, that they are material particles. So any particle, they will definitely, we have already know that their charge is negative. But what is the mass? Because we know that small or less, each and every particles do have mass. Each and every particle present in nature, present in universe, maybe the particle will be exactly small or big, but it do have mass. Okay, so we should know the mass of electron also, because we told that the cathode rays are having negatively charged particles, and we have named this negatively charged particle as electron. Now we are exactly going to do another work. We are going to find the mass of it, charge and mass of it. So charge to already we know. So for determining the ratio charge by mass, E by M of electron, using a special type of discharge tube, J.J. Thomson in 1897 studied the extent of deflection of cathode rays under the influence of electric field and magnetic field. Okay, so that is not important for you, but one thing is there. We came to know about the mass of electron. Okay, mass and charge of electron. No, today maths class is not there. Today maths class is not there, beta. Today maths class is not there. The charge of electron and mass of electron. So what he has done, so Millikan experiment was there. Millikan experiment means he has done one experiment, with the help of it he got the charge of electron. So exactly the charge of electron is 1.6 into 10 to the power minus 19 coulomb. Okay, what is the mass of electron? Charge by mass is 1.76 into 10 to the power 11 coulomb per kg. This is charge by mass of electron. But what is the charge of electron? So which one is more important for you? I am just underlining the charge. So negatively charged electrons, the charge of electron is 1 negative. But what is the charge of electron given? The charge, hence conclude that the charge of electron is, each electron is having a charge of 1.6 into 10 to the power minus 19 coulomb. 1.6 into 10 to the power minus 19 coulomb is the charge of electron, is the charge of, that is 1 unit negative charge. 1 unit negative charge of electron constitute 1.6 into 10 to the power minus 19 coulomb, okay, charge. Yes, correct only, Manpreet. Manpreet, charge is only important, yaar, mass is important. So only charge by mass I have not say. I didn't discuss about charge by mass, huh? So now we are going to go towards the next concept. So back to back whatever I taught today, I just want to know about it. Okay, because if I am going to put everything in one frame now, you will definitely get destroyed. I'm just joking, I'm just discussing about charge by mass ratio is also given here. So we have exactly discussed some very important point. Cathode ray discharge tube experiment we were discussing about. Now I'm asking some question related to today's class. Back to back, get ready everyone. Yeah, air is also having mass. Density is there, na? Density is equal to mass by volume, and you know that what you called air is also having mass. Who said that air do not have mass? When you will go in higher altitudes, definitely you will be experiencing that absence of mass. Okay, so definitely density will be there. Ready everyone, come on, super. So now we are going to discuss about some of the content what I discussed. How to prove that cathode rays are negatively charged. How J.J. Thomson proved that, or how to prove that cathode rays are negatively charged. For proving that cathode rays are negatively charged, what J.J. Thomson has done? What J.J. Thomson has done? To prove that cathode rays are negatively charged, what he has done? What he has done in the experiment? What he has done in this experiment? Yes, by the experiment he has done, but what he has done in that experiment, I want to know that, because I have shown you different type of discharge tubes, and in that discharge tube there were extra fittings. With that they came to know about that cathode rays properties. Okay, so what he has done? Experiment, so we are discussing only about experiment. You have to just type, he put magnet. Very good. So either he has kept magnet or electrical field. So if you will be keeping magnet or you will keep an electric field, here you have seen that, see, this electric field has been applied, or you can keep magnet also. In that, what is exactly done is, that's what Shrutika has asked this question from me, that is this exactly, Rahul, by using positive magnet. Yes, the magnet will have positive, means north pole and south pole, one side will be deflected towards. So with that also we will come to know, but the most important thing is electric field as having positive terminal and negative terminal. So the cathode rays are deflected towards positive side, which is indicating that, and it is moving away from the negative terminal, which is exactly giving a concrete proof that cathode rays are negatively charged. Cathode rays are negatively charged. Okay, now next question is, cathode rays does not produce heating effect. Am I true or am I joking? Cathode rays means, am I true or false? Cathode rays do not produce heating effect. Cathode rays do not produce heating effect. Magnet and charged rays, absolutely beta. Correct, Manpreet. So cathode rays do not produce heating effect. Am I true or false? Yes, because now only we have seen that they have penetrating power. They have penetrating power. That means 100% they have heating effect. They can produce heating effect. So that means the statement that cathode rays do not have produce heating effect, it is a wrong statement. Next important question, how to come to know that cathode rays have material particles? How to come to know that cathode rays have material particles? How to come to know that cathode rays have material particles? Come on, quickly answer the question. Cathode rays have material particle. Material particle, material particle. I am just repeated the content 2-3 times. They have kinetic energy. The rays are traveling, Manpreet. The rays are traveling, but it has done one activity. By the help of that activity, we came to know that it is having material particles. It is having material particles. It is having material particles. What they kept in between? Absolutely, Rahul. They kept one mica pedal, okay, very lightweight mica pedal. They kept in between the cathode rays, because the cathode rays are moving in straight line. So they kept a metal that is a mica plate made what you call like fan like what you call. They have kept, and you know what happened when this cathode ray exactly past cathode rays were traveling. It started rotating these pedals. Okay, they started rotating this pedal, and this proved the fact that the cathode rays are exactly containing material particles. Cathode rays are exactly containing what? Material particles. Okay, so they have exactly, they are negatively charged and they contain material particle. The next important question is, at what atmospheric pressure the what you called the cathode rays got emitted from cathode at what particular pressure the cathode rays has been emitted? At what pressure the cathode rays has been emitted? At what pressure the cathode rays has been emitted? Let's see, are you listening to me properly or not? So this is what I am just going to check, that you are listening to me properly or not. Absolutely correct, Vishal. That is a very good answer. That is 0.001 mm. Correct, Rahul. Rahul, 10 extra you have put. So 0.001 mm of atmospheric pressure. See, the cathode ray got emitted from cathode. Cathode rays got emitted from cathode. So that was the next important point we have seen in that. Fine. So we discussed about cathode ray experiment today. Now next we are going to understand about protons. So protons are positively charged, and now proton discovery has been seen. We talked about J.J. Thomson experiment. Now we are going to discuss about discovery of proton. So we know that proton discovery was done by Goldstein, and then I think you know about neutron. Neutron was discovered much later, because you know what, initially we were understanding one thing at the time when electricity, that exactly it is having two charges, one positive charge and negative charge only exist in nature. But after that, when after Rutherford experiment only now we started talking about atomic structure. Then after understanding about atomic structure, then when the structure of atom was exactly understood, after that only we came to know that no, the nucleus is exactly not only containing the positive charges, it is having something neutral in it. Because we have to understand one thing now, ki when same charge will be there na, so they will repel each other. So you think about in nucleus, if only proton will be there, then proton will be able to live together. Proton. It is not only one proton na, because when atomic number is increasing, we are seeing that more than one proton is there in the nucleus. Yes or no? And how many protons are there in the nucleus? That many electrons are there in the extranuclear part. Simple logic is, electron and electron are having repulsive force. Then why proton will not have repulsive force? 100% proton and proton will have repulsive force, because they are same charge and same charges repel each other. Then to bind this repulsive force or to overcome this repulsive force, exactly neutrons are present inside the nucleus. So between two proton, neutron will be there, and this neutron binds the repulsive force. This neutron do what? This neutrons binds the repulsive force of proton present inside the nucleus. I hope you might have understood. So protons are positively charged, electrons are negatively charged, and proton inside the nucleus is exactly having neutrons also with them. So why neutrons? It is just like you and your friend are very fighting always with each other. You both are like same. Then another friend will be there which will always sit between you and your friend who used to fight a lot, so that your fighting should be reduced. So to reduce this repulsive one, 100% something should be there in the nucleus, and that means the nucleus in the nucleus, neutron will be there which will overcome the repulsive force of proton. I hope you might have understood. Counterbalance the repulsive charges, beta. There is one word called as pi meson charge. Pi, M-E-S-O-N, pi meson charge. So that is exactly binding, and you know what? This binding force generate a type of nuclear charge, and this nuclear charge is exactly coming from the nucleus. So you know, this is the strongest force. The force which is holding them together is the strongest force. That is the strongest force in nature. And you know, the nuclear charge which is coming out from the nucleus now, it is capable of, it is a type of attractive charge, and it is exactly attracting the electrons present in the extranuclear orbit, and that holds the electron in the extranuclear orbit. So there are many things, time to time we are going to discuss. So tomorrow morning again I am going to talk about proton. So we are going to discuss about proton, and then we are going to talk about neutron in tomorrow's class. Fine. I hope today's class you have understood the content nicely. Manpreet, I think you are in which class? You are in 9th or 10th, because 10th periodic table I am going to teach today. At 7 o'clock. At 7 o'clock I am going to teach periodic table. There I am talking about atomic radius, ionic radius. So today most probably I am going to talk about ionic radius, cation and anion. So most important point I am going to discuss there today. Okay, 7 o'clock. Bye everyone.